All right, good morning. So we have solved trig equations in a couple different ways, just by factoring or by other strategies. How my thing is not focusing. Let's see. There we go. All right, but we're going to solve them now by incorporating those identities that we've been working on. So you have your identity reference sheet. Hopefully you have it somewhere nearby. I don't expect you to have these memorized, but I do expect you to be able to look at them. So let's look at an example of how this might work. And there's going to be a lot of different ways that you could do these types of problems. But sorry, I should have written it first. I'm just going to kind of give you a couple examples and some strategies that you can use as you go through and practice. It's going to take practice to learn this, not just watching a couple examples. So when I look at this problem, the first thing that I look at or look for is how many terms does it have? And this one has 1, 2, 3, 4 terms. There's a couple ways you could do this. I'll show you kind of what I did first. I don't know that it was the best way. Actually, I'm going to do it a different way this time. We want to find the solutions between 0 and 2 pi. So our answer is going to be in radians. Because this has 4 terms, we're going to factor it by grouping. So we're going to group the first 2 terms and we're going to group the second 2 terms. Please keep in mind that this is an entire term. There are no pluses and minuses in this part, so it's one term. This is one term, but obviously together it's 2. So we look for GCF, and our GCF is the square root of 3 times tangent x, and we're left with cotangent x plus 1. The other GCF is -1, so we have 1 plus cotangent x equals 0. At that point, we can say, okay, these are the same. Now, if this was a minus, they would not be the same, and you would have to do some manipulation. But since they are both plus, it's the same. So we have the common factor of cotangent x plus 1, and we have the square root of 3 tangent x minus 1 equals 0. And so far, we haven't even used any identities yet. We're going to separate this into 2 parts and solve each one. So we're going to add 1 and divide by root 3. And over here, subtract 1. So cotangent x equals -1. All right, now we're going to think about quadrants. When you look at these numbers, they are ones that should kind of pop out at you as special right triangles or quadrantal angles. And so you don't need to use the inverse function at this point. Which quadrants have cotangent as negative? Well, in quadrant 1, they're all positive. In quadrant 2, sine is positive. So this could be in quadrant 2. Tangent is positive in quadrant 3. So quadrant 4. Although I wrote that and then I just was like, wait, hold on. If you look at this on a graph, that's a quadrantal angle where cotangent is negative. Oh, no, it's not quadrantal. Never mind. Sorry, I'm just still waking up this morning. So cotangent -1 would be in quadrant 2 or quadrant 4. In order for it to be -1, you can see it would look like that. And in order for those to be the same, this would have to be a 45-degree angle, but we are not in degrees, we're in radians. So a 45-degree angle here is 3 pi over 4, and down here would be 7 pi over 4. You'd remember from the unit circle. As far as tangent of 1/3, again, this is positive. So now we're going to be in quadrant 1 and quadrant 2. So I'm just going to sketch that. just in case you still need to sketch them. And that would be opposite over adjacent. So this is a 30-degree angle, and the corresponding radians would be pi over 6. And then this one would be 7 pi over 6. So these are the answers, the solutions. And you can check that on Desmos by typing it in and looking at the x-intercepts. All right, I'm all warmed up now. If you are confused about any part of that, then go back, watch, pause, do what you need to do, or you can obviously ask me. Also, this is just a sketch to help remember. You don't have to do that part. And we didn't end up using any identities there, so let's just use that one as a review. All right, we have tangent x equals sine x. Remember, the instructions for solving were most of the time to get it equal to 0. So we're going to subtract sine x from both sides. So on this side, we have tangent x minus sine x equals 0. Now we would want to use an identity. What do you think? Just think for a minute. What do you think you would want to use for an identity here? The tangent is sine x over cosine x. So now I'm going to replace tangent x with sine x over cosine x and keep my sine x here. This is a fraction and this one isn't. So we're going to make it into a fraction by multiplying by sine x, just like we did before. I meant cosine x. I don't know why I wrote sine. I guess I'm not as warmed up as I thought. So we're going to have sine x over cosine x minus sine x cosine x over cosine x equals 0. All right, I'm going to combine this all together. Sine x minus sine x cosine x all over cosine x equals 0. So what I did at this point to make it a little bit easier, and there are other ways, but I kind of was like, ooh, if I cross multiplied, I could get this to equal 0, and that cosine cancels out. You could also choose to multiply by cosine on both sides. It's the same thing. And you get 0 equals sine x minus sine x cosine x. And now you can see we can take a GCF. So a GCF of sine x, 1 minus cosine x equals 0. We have our two factors now, and we can set each factor equal to 0 and solve using the zero product property. This one's already solved. This one, we need to subtract 1 and then divide by -1. These are not in quadrants, they are quadrantal angles. So think about where sine x equals 0. Remember that the coordinates cosine x, sine x being y. So picture on a graph where y is equal to 0. Let me draw it for you. Y is equal to 0 on the x-axis. So if you picture the unit circle there, this would be 1, 0, and this would be -1, 0. So at 0 degrees, or 0 pi, at 180 degrees, or pi, is good. And we can also go all the way back to 2 pi. We also know that cosine equals +1 only right here at 0 and 2 pi. So here are our answers. And if you graph it in Desmos and look at the x-intercepts, you will see those spots. All right, let's look at one more, and hopefully that will be enough to kind of get you moving. Hopefully. just with the idea, because you should be okay with using the identities at this point. All right, so one more example. Let's see, what do we want to do? Let's do this one. Sine 1/2 x equals cosine x. All right, so you should be like, oh my goodness, what can I do? But hopefully you recognize this as the half angle identity. So you're going to look at your reference sheet for half angle. There are the half angle identities, and we have the sine one. So on this side, we're going to put plus or minus 1 minus cosine x all over 2 equals cosine x. All right, now if you were doing one that had a tangent half angle, you would kind of want to decide what you wanted. Do you want only cosine, or do you want sine and cosine, which will help you more. All right, how do we do this? Well, what is the opposite of a square root? Squaring. So we're going to square both sides. When you square a square root, you just take off the root, and cosine x squared is cosine squared x. I'll do it this way this time. I'm going to multiply both sides by 2 to get rid of the denominator. So we have 1 minus cosine x equals 2 cosine squared x. We want to make this equal to 0. So I'm going to subtract 1. And also I'm just going to do this in one step, add cosine x. So 0 equals 2 cosine squared x plus cosine x minus 1. I just kind of rearranged it using the commutative property to put it in the order that I prefer. Now we need to find the factors. It's quadratic with 3 terms, so we're going to multiply. 2 times negative 1 is negative 2. What are the factors of negative 2 that add up to positive 1? Negative 1 and 2. So I'm going to replace our middle term with minus cosine x plus 2 cosine x and keep the first term and the last term. Now we have 4 terms, so we can factor by grouping. The GCF of this group is cosine x. So we have 2 cosine x minus 1 left. Our second group does not have a GCF, so we put plus 1. The GCF is 1. 2 cosine x minus 1. We have our common factor, 2 cosine x minus 1, and our leftovers cosine x plus 1. Once you are down to just groups of factors, you're going to set each factor equal to 0. And solve, so I'd subtract 1, cosine x equals negative 1. On this one, I will add 1, and divide by 2. All right, now let's figure out where these would be located. Cosine x negative 1, the x coordinate is negative 1, would be on the negative x-axis. So looking at a graph, it would be out here. So we have pi, or 180 degrees for that. Since it's negative though, it might be 3 pi also. Oh no, it's fine, it's fine. All right, the next one, we have cosine is positive 1/2. So this could be quadrant 1 or quadrant 4. If it helps you to draw your reference triangles, then do that. And you will see that this is a 60-degree angle, in which case it would be pi over 3. And back down here, 5 pi over 3. Those are the answers. So I feel like I could give you 50 more examples, but I don't know that that would be helpful because you really have to figure out how to do this by practicing. So you're going to see many different substitutions. You're going to need to look for half angles or, for example, double angle right here. In this one had a double angle. This one has a Pythagorean one right here. So instead of cosine squared x, I put 1 minus sine squared x to get it all in the same. So you're going to have a lot of options. It's just going to take some practice. Good luck and have fun.